House of Sultan and Sons Private Limited and Method AI extend a very warm welcome to all the participants of today's artificial intelligence webinar. It feels nice to have you all here, and we thank you for that. A bit about the House of Sultan Chand first. Pioneers in the field of book publishing in post-independence India, we cater to students from pre-primary to university level, churning out over 600 regular titles, besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in reputed schools, colleges across the nation, as well as in some neighboring countries. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. I now introduce you to the host of today's webinar, Dr. Sachin Gupta. Besides authoring artificial intelligence and data science textbooks for classes 9th and 10th, Dr. Gupta is Dean Research and Innovation, Maharaja Agrasen Institute of Technology, Guru Gobind Singh Indraprastha University, Delhi. It gives me immense pleasure to inform you that Dr. Gupta has added another feather to his cap. His latest book on AI, Decoding Artificial Intelligence, has won the Outstanding Contribution to AI Literature Award recently. A great feat indeed. Besides, Dr. Gupta has also been HOD, Computer Science Engineering and MCA Department, Dronacharya Group of Institutions, Deputy Director and Head, Computer Science Department, Chandraprabhu Jain College of Higher Studies, affiliated to GGSIPU, Delhi. With a teaching experience of over 20 years, which includes teaching undergraduate students, postgraduate students, and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIPU. Dr. Gupta has also contributed to various journals, conferences, and books for his school and higher education, both nationally and internationally. His achievements are truly commendable. May I now request the man of the moment, Dr. Sachin Gupta, to take you through today's session. Dr. Sachin Gupta, have a great day ahead. Thank you.
Thank you so much, sir. You are very kind with the word. Thank you so much. And thank you so much for everyone who has joined today for the session. I'll brief a bit about computer vision. This is one of the topics which I keep very close to my heart. This is a topic which I feel very interesting to speak about. And this is also a topic which is very typical. People understand that it is a little hard to understand, because computer vision actually speaks about two things together. There is one part of it which is image processing, that anybody who was into traditional computing, they would know. And the second part is artificial intelligence and machine learning. That is something new. And it actually brings both of them together in a huge way. The applications are immense. We are using it on a daily basis in our apps, in our programs, in so many things, your biometrics and all that we are going to discuss. But we are planning to deliver this session broken into two parts. The first part would be understanding as I said, that there is a lot of information about how images are processed, how images are formed, how images are actually, what are the features of images. And then we will take on in the next session that how to use artificial intelligence and machine learning to learn from that. There are several challenges which computer vision actually works on. It also faces a lot of challenges. And we are going to keep this interactive, that there would be a lot of queries that you might have. And I would actually love to have them. I may not answer them immediately the moment you ask it, but I promise that you will have an answer maybe by the end of the session, or maybe you can write us a mail and I'll definitely address those queries. So I prepared some introduction about myself, but Manmohan sir has already given you enough information, so I am going to skip this slide. But you are the inspiration for the new title, Decoding AI in class 9th and 10th, for which we just got an award. Congratulations to my publishers and the editors also. Thank you so much, sir. Okay. So what we are going to cover today is what is computer vision and machine vision. They are two different things, to be very honest, because computer vision would deal with only how computers see things or how computer perceives images, and machine vision is more related to robotics. That how do robots or how do self-driving cars they see, operate, alter their course, and a lot of things. Then in the first part, we are going to discuss up to image representation that we are going to cover today. The point 3 and 4 that we are going to keep it for the next session on the series. Okay. So computer vision basically, as Wikipedia defines it, from the perspective of engineering, even in the machine language general jargon, we say that artificial intelligence is basically the process of automating those tasks which the human intelligence can do. So for computer vision, we are trying to automate the task which a human visual system can do. Like we can acquire images, we can see things, we can process what is happening in a scene, and we understand what is with the imagery. Similarly, when we talk about computer vision, we include the task for acquiring images, processing, and understanding when it comes to digital images. So that is a basic prerequisite that an image that we are working with computer vision has to be a digital image. And this is again going to be the focus, that what is a digital image? How are we going to be able to process the digital images? So why is it gaining relevance in the present era? Since the last 7-8 years, computer vision has come to the forefront of every technology. These days, almost 80% of the data traveling on the net is visual. We are not talking about only images. We are talking about memes, we are talking about videos, we are talking about shorts, we are talking about everything that your social media keeps you engaged in. That most of it is now moving from text data to images. So everybody has a smartphone, and every smartphone has at least two cameras. So there is a front, there is a back camera, and we are taking a lot of pictures, which eventually end up on the internet. There are a wide set of applications which computer vision applies to, including robotics, then surveillance, then industrial applications, self-driving cars, drones, buses, and the medical uses, as you can see in the image enclosed. They're not limited, there would be more. So what tasks does computer vision perform usually? The very first task that computer vision helps us to do is classification. That when you see this image, what all do you see? What all are the parts in the image? Now, mind you, there are two perspectives. One is, as a human, we are gifted with that this intelligence is very easy to us. That we can see a picture, we are able to understand that there is a clock, there is a car, there are some people moving, it's a road, there is a building, there are flags in the. But a computer does not have intelligence. A computer can see an image only as a set of pixels, something like data. So computer vision is actually addition of intelligence to an image that allows us to understand, that allows computers to understand what is happening in an image or what is happening on a scenario. So classification is the first task that computer vision helps us with, that what is in this image. So you can see there are people, there are cars, there is a traffic light, there is a clock, and likewise, there are several other things which you will be able to see. Classification is the first task. Then the second task which computer vision helps us to work on is detection. That besides our first task. So first thing was that we need to classify what all are the objects there. Then where are these objects located? So on this image, the clock is bound with a green box, then a person is bound with a blue box, then the car is bound with an orange box. So these are the things which are allowing you to be able to see that within this image, the computer vision was not only looking at classifying different objects as this is a car or this is a person or this is a clock, but also locating that where is this particular image located. That is the second part called detection in computer vision. The third task in this series is that how do I segment? How do I make different pixels which constitute a clock? Because from the previous image, we could broadly place the clock within a bound. We could broadly place a person within a bound. We could broadly place a car within a bound. But which particular pixels or which particular building blocks of the image actually constitute the clock or the person or the car, that part is called segmentation. So what is in the image? That question was answered by classification. Where it is was answered by detection. And in which pixels is that specific object located is actually the part segmentation. All right. So for segmentation, there is a very popular library by Meta currently that we call as Facebook, which you will enjoy working with. So there is a site called segmentanything.com. This is from the developers of Meta. And they have included a demo which you can be using in your classroom. You just have to accept their condition. And they have a set of images which any of these you can use. So for these images, let us say there are images from biological domain, there are images from painters, there are images from people who have taken digital images from various objects. So this is an example which I usually take up. So from this, when you hover on the image, you can see that the moment I hover on the dog, I can see this is a distinctive. So this part is, there were three things happening here. One was that I could classify the image into several different things. There were trees in the background, there is a dog, there is grass. Then I could locate this using the detection, and finally the specific set of pixels which constitute a dog that can be separated. Right. So I can add a mask, I can add more images, and so forth. So this is an example of segmentation. So you can segment everything in the picture, and you'll be able to see that how computer vision is working in the background to now create every different object segmented, that the set of pixels which constitute each of the different objects that have been detected, classified, and broken up into parts. And I may want to actually see the cutouts also. So we may cut out each part separately by using the tools for adding mask. You'll be able to work with and looking at it. There is a huge data set that you have here. Choose whatever that you want to work with. Right. So there are 11 million images in the data set with the 50,000 only that they have included for the demo. So it's a huge data set that of cost. So moving ahead, so far that we have understood that there is classification, detection, and segmentation. These are the three parts that we are obviously working with the computer vision. But now we speak about pixels. And this is one of the most misunderstood topic in computer vision. So pixel is in basic computer graphics. Whenever we want to draw a digital image, a pixel would be the smallest unit that we can manipulate. So pixel changes its definition. Every once in a while, you will have a different definition of a pixel because the pixels vary on the basis of a lot of parameters, that whether our image is black and white or whether our image is colored, whether we are showing texture, whether we are showing colors with a different depth, and so forth. I missed on a task of computer vision that says that you can also annotate. This is some project that my students have been working on, research students, and with the large language models that have come in. So what does this image portray is a people crossing a street while a car is waiting. So you can see that normally a computer would not be able to understand the nuances of this image. But with the large language models, with the understanding of the image that computer has done, it would be able to detect, classify, segment, and finally be able to say that this is what is happening in the scene. That is called annotation. So annotation is happening across pictures. It's also happening across videos and so forth. So you can now say, give an image to a system which is working on computer vision and ask it to tell what is happening. There's a reverse also happening. Reverse is also happening in the scenes like I'll give you an app.leonardo.ai. So what we just discussed was annotation. How would you describe the picture? The reverse should be when you say a prompt that generate this image. Your computer understands what you want to generate. It is going to pick up the objects which it has learned over the years into some databases, and then it will try to put them together and create an image for you on the basis of what is the prompt. So Leonardo is a free app, and there is image generation which you can do. All right. So let us try to generate an image with some input. We'll say uh, a busy crossroad with a clock tower, people crossing, and a car waiting. See how beautifully this is happening, that we just have a prompt. We did not have an image prior, but the large language models allowing us to integrate computer vision with the prompting, and I hope to generate some image which is good enough. Hey. So these are the set of 4 images which it is giving us. You see that there is a clock tower, there is a car waiting, there are people crossing. This is the power of computer vision when it integrates with artificial intelligence and machine learning. So you can generate your own set of images for whatever reason that you might be working with your classrooms, with the projects that your students are working on, and you can use the app. There are 150 credits in the app. That means you just used a total of 8 credits for these 4 images. You can use all day long and you'll never fall short of imaging. So annotation was one, and reverse of annotation also we saw in the picture right now. Okay, I hope to have any queries on the chat box. In case you have anything, please do feel free to ping us. I'll read the question and try to answer it immediately. So the next part is that there are more tasks to computer vision, like face detection. This you all must have already seen. Most of the mobile phones are now coming with software which can identify faces of people in the image. This allows you to click pictures which are not blurred, which are clearer, where people are centered in the image. And then uh, there you can see all the tasks clubbed together into one single image, where there is classification, then semantic segmentation of the balloon, then object detection, and instance segmentation, where we are even with the same type of objects, we are classifying them separately into different. So this is the part one of what basically computer vision can do these days in our setting. There can be a lot of combination of the tasks that we have seen. That means object detection and classification. So this is a picture taken from YOLO, a computer vision model, which allows us to identify different objects in an image, annotate them with what it is looking at, and classify them. See, the colors are for classification. So every person is depicted in a purple. All traffic lights are blue. Then all cars are yellow. The truck is a different color. The handbag is a different color. Whatever it is seeing in the image, it has detected the object, it has classified the object, and it has annotated the objects, even segmented them into different portions. So this is all in all put together what computer vision works like. And it is not just that you are going to have computer vision working with images which are static. Look at an example that it can happen with real time imagery also. That means if a traffic person, if a camera is blessed with computer vision setting, it would be able to identify your car as it approaches. It would be able to read the number plate. It would be able to see whether you are wearing a seat belt or not. It would be able to see whether you are actually talking on a phone while driving the car. And there are a lot of challans coming your way if it is endowed with computer vision. So be careful when you are on the road these days. Almost all the cameras that government is putting, they are blessed with the computer vision setting, or they are going to be very soon. So image representation is a very complex topic. How many of you can actually make out what the image is? Try to squint your eyes a little and you'll be able to tell me on the chat window that this is this famous personality in the image, which is completely blurred, the human intelligence part. Can somebody tell me in the chat box, who do you see here as a person? This is just a pop quiz. This is not something that we are looking for. Okay. Abraham Lincoln. All right. That is human intelligence in work. Thank you, Ashin Prakash Jain. This is iconic. This picture is iconic. This is indeed a picture from Abraham Lincoln, the American president. And the images, we can see the pixels. We can see the intensity of the pixels. We can see the pixels, only the number of the intensity in that image without actually looking at how the computer sees it. So let us go further into what is the representation of an image. So on the screen now, this is the image that we are talking about. There's just a small square with 4 dots. We'll assume that each one of them is a pixel, right? So this image, any image inside a PC is just a matrix of numbers. So for the PC, for the computer, the image is nothing but it's just a series of numbers, right? This is a bitmap where I have only 2 colors for representing every image. Either my pixel may be white or the pixel may be black. So for everything which is supposed to be white, I'll use the number 1. For everything which is supposed to be black, I'll use the number 0. Right. And mind you, this is inverted. When it comes to displaying, that inversion happens. So wherever you are seeing a 1, that ideally should have been black, but an inversion happens. So on this, for the purpose of understanding, you may actually simply say these are all might be 0, that these all might be 1. It wouldn't actually make any difference. But the gist is that your image would be having only 2 colors, black and white. The image dimensions are, you can see this is the 4x4 matrix, right? Similar here. With this 4x4 matrix, I am also adding another dimension, cross 1. This 1 is for that color depth or the number of color channels that I am using. So I have only a single color channel. This is black or white. A single bit of color depth. That means for each pixel, I am using a single bit. I repeat, for each pixel, I am using a single bit of information that would be either 0 or 1. If it is a 0, my computer is going to paint it as a black or white, depending on whatever the number you are going to choose for your images. And the total number of pixels for creating this image should be 16. So 1 bit each for each of the matrix values. And together there are 16 values. So my complete image would be only 16 pixels in size. All right. 16 pixels, 16 bits. Both are 16. So this image is 16 pixels. Each pixel is 1 bit. So we are saying this is a 16 pixel, 16 bit image. That's all. Let us add a little more complication. What if I would have a scale of gray. What if I would not want only black or white, but I wanted an image which had a lot of shades of gray instead? So this is my second representation. Here you see we have a image which is the same dimension, 4 cross 4 cross 1. There is a single color channel which is either black or white or grayscale, as you may want to say. The color depth, however, is 8-bit. This 8-bit means that for representing every pixel, I am using 8 bits to store the information about it. So in computer science, everything runs in the power of 2. It's a binary number system. So for 8 bits, we'll be having 2 to power of 8 total possible representations, so total possible numbers. So 2 to power of 8 is 256. I repeat, with the 8-bit image, I would be having for each pixel, I would be representing one pixel with 8 bits. For 8 bits, I may have 256 different possible combinations, or my values for these pixels may range from 0 to 255. So 0 may be black, 255 may be white, and anything in between is like this is 217, this is 0, this is 127, this is 191. Likewise, different shades of gray would be represented by different values, but the range would be between 0 and 255. And for representing the 0 to 255, I require a 8-bit color depth. So the size of the image should be, can somebody tell me what is the size of the image in bits now? On the chat window again. In pixels, the image size is same, 16 pixels. The size of the image in bits would be, I am opening the chat window. There is no fastest finger first. This is something that we want to run slowly and understand it. Any answers there? What is the size of this image? Okay, this would be 16 bits, 16 pixels. For each pixel, I have into 8 bits. Perfect. So it would be 16 cross 8 because we have each pixel being represented by 8 bits. So there are total 16 pixels. We would be having 128 bits. Naya Sani, perfect answer. This is what we were looking for. So this is something that we are now progressing from the previous image, which was just a single bit per pixel to 8 bit per pixel, where we are now adding grayscale. What if we had 2 channels instead of 1? The color channels may be red and blue. I'm not taking a third one. For the representation only 2 channels. And then try to take it further. So my mix of the red and blue. And my image is now, the color depth is 8-bit. That means for each pixel, I would be using 8 bits. But the 8 bits which I were using earlier were only shades of either white to black. Now I am using a color depth of 8-bit, but the shades are either red or blue. So part of my image would be, let us say this matrix corresponds to red. So for 255, it would be complete red. For 0, it would be blank. It would be nothing. It would be plain, maybe colorless, right? But for this part, the second matrix that we have, we would be having 255 as the complete blue and 0 for a blank. That means it's colorless. When we overlap these two together, this remains red, this remains blue. Here we have more of red, so you can see 170. Here we have more of blue, so you can see 170 here. Here for 170 more of red, but there is a bit of blue, 85. So mixing a lot of red and a bit of blue gives me this color. Mixing a lot of blue and a little bit of red gives me this color. And this is why our image looks something like this. So the number of color channels here is 2 instead of the previous that we had a single color channel so far. We have now added 2 color channels instead of 1, red and blue. The number of pixels is now 32 because there are 2 matrices, each one representing 16 pixels. So total images in this total pixels in this image is 32. The color depth is still 8 bits. So you can automatically calculate we'll be having the size of the image to be 256 bits. Correct? So my dimensions are 4 cross 4 cross 2, where there are 2 matrices of 4 cross 4 each representing 1 color channel. Accordingly, the images which we use nowadays are RGB, red, green, and blue. There are 3 color channels. So your dimensions would be 4 cross 4 cross 3. Right? The color channels would be red, green, and blue. With red, green, and blue, you can make almost every color. And the number of pixels would be 16 cross 3, that is 48. If it is a 4 cross 4 matrix, it would be total number of pixels would be 48. I hope you get the gist of what is happening with the image representation so far here. Any question that I may answer? Okay, one question was from Anju Jaiswal. Yes, Anju, we can use MATLAB for image processing. MATLAB is basically reasonable for using image processing because of this property that all images in computer science are represented with matrices, and MATLAB is a synonym for matrix laboratory. So it is very convenient and it has been used over a lot of years for digital image processing as a software. So MATLAB uses the language R, or you can use R, another language, or Python, or MATLAB, certainly is very conducive to it. Any other questions so far?
Thank you, sir.
Sure. Okay, so this was for the image representation that we had. Now, how does computer science deals with, or how do we think about technical terminology when it comes to image classification? The first step that we said. So the intuitive steps as a human being, that if I have to think about processing an image, we would have to break it into parts. Then we have to identify which are the important distinguishing components within that image. We convert them to some standard format. We store the rules and we classify that. We say that this is something having a tail, some eyes, this looks like a dog. That would be the rule kind of thing. So corresponding to this, the technical terminology that we are going to cover later is that when we break an image into parts, it's called segmentation. When we identify all the important distinguishing components of an image, we call it feature identification, that which features are important. Like we'll discuss this later. What is an edge? What is a corner? What are the channels and everything? They are the features. We convert them to some standard mathematical format. In computer science, we call it a vector space model. This is beyond our requirement for the topic. We store the rules as a machine learning model and we classify. The classification operation would be the same in either case. Correct. But let us go back to this. What do you think is the feature in this image? What is something that the image is made up of? That is the pixel, the unit of, if I have to identify what is in the image, I have to identify what is in the pixel. Right. So that pixel is the lowest level feature in any image that we are going to work on. So now think about it, that how many features are we working on? How many features are we talking about here? This is the beauty of computer vision, that images these days are big. If you imagine a 2400 cross 1600 pixel image, all right. So my images, when I say dimensions of an image, let me go back. This image is 4 cross 4. That means 4 across the 4 pixels across the breadth and 4 pixels across the depth. Right? If I say my image is 10 cross 4, so this would have been 10 pixels across the breadth and 4 pixels across the width. So when I say my image is 2400 cross 1600 pixels, that means there are 2400 pixels across the breadth and 1600 pixels across the width. And each of the pixel is a feature. Each of the pixel is a feature. That means there are 38 lakh 40,000 features in this image. And that's what makes computer vision very challenging. Challenging because in every machine learning model that you are going to discuss, that we have discussed, is there a question? Okay. So, so far, what we have learned in machine learning and artificial intelligence, that we try to learn from features. So I may have had a student who says that this is the number of hours he studied, this is the number of hours he plays, this is the number of hours he is revising, and we want to predict the academic performance of the student. So based on these three features, we might want to predict this, the feature which we want to create as a target. So everything which is in a tabular data set, which is a column, that is a feature. So for normal machine learning, the features are usually maybe 10, 16, 100, not more than that. But for computer vision, where every pixel is a feature, the number of features is so huge that it becomes very difficult to work with the computer vision along the lines of machine learning. So the biggest task with computer vision imaging is how to reduce the number of features to a manageable number. And most of the computer vision task is related to that we will convert the image from high resolution to a low resolution first. Then from low resolution, we are going to remove some color information. Then after removing the color information, so looking back, if I have to, if this was the image, this had more information. This had two channels and this had 32 pixels. I wanted to reduce it to some extent, that keeping the image structure same, I would just reduce the number of color channels to 1. This automatically reduces my image to only 16 pixels and 8-bit. I wanted to reduce it further. I may just simply convert it to a bitmap, and now I have the primary basic image from which I can make out the structure. So this is what usually the steps in computer vision are, that we will take a image which is high resolution, break it into a smaller, lesser resolution image, then remove some color information, then remove some bit depth of the image, and finally start working with identifying that what is the shape that is coming out to be, because those shapes are the ones from which we are trying to learn. All right. So this is what happens with usual. Any questions here? So, see, the image goes from an image having a lot of features. We may want to crop out some, we may still want to crop out, and there is still a lot of information because the colors in the image are a lot to process. So how do you expect that, given this is a large number of features, will ML ever be able to work? So fortunately, the functions which machine learning works, they are not taking all mathematical possibilities. They are only going to take a couple of features which are identifying. So machine learning does what? It takes small amounts of input knowledge and it converts into large amounts of output knowledge. So it can learn from a small set of features and it would be able to generalize them to a large number of examples also, which are having similar classes, similar features, and so on. So once the machine learns that this is an image of a dog, you give it 10, 15 different examples of breeds of dogs, and it would be able to predict 90% of the total number of breeds of dogs available in the world correctly. Not all 100%, but 90%. So taking only small amounts, that out of 3,800 breeds of dogs, if I am giving images only for 10 or 15 breeds or so, ML can learn the features of them and it would be able to apply that knowledge to anything which is having a similar feature or to convert it into a class. So machine learning is not magic. It cannot get something from nothing. It just gets more from less. So you feed it a certain number of examples, it starts learning from that, and it would build everything from scratch. It allows your learners to combine knowledge with data to grow programs. All right. So there are some challenges with computer vision, obviously. What do you see here? The images. Just describe the first image for me in the chat window. Anybody? What all do you see here? If I am feeding this data to a machine to learn from, what is it going to classify it as? These are puppies, right? Dog faces. Anything else somebody sees? It's not a trick question. It's a very simple thing. There are cupcakes. They are usually used to confuse the machine learning data. So this here is a cupcake. This here is a cupcake. There are a lot of cupcake images within that, but they look so similar that if I have to ask a machine learning model to be able to distinguish between dog features and cupcakes, it would be very difficult for them. So this is one of the challenges where different classes of images look similar. Then uh, within the class also, like you call a class as a chair class. So chairs have so many different variants available in the real world that real world never maps exactly similar to what computer vision expects it to do. So for this, the legs are straight, the back is curved. For this, the legs are having wheels and the back is a bit different. There is the legs start from different locations. Then this is. Then scale is one big problem, that the same image might be coming into a very big shape object or very small. Then where are we looking it from? Are we looking it from the top, from the side? What is the viewpoint? That image changes immediately. For humans, it comes to them very naturally. You see a chair from any angle, you'll understand it's a chair because it's a 3D vision. Computer does what? It converts every 3D to 2D first, and it becomes very difficult for them to understand that this is the same chair that I saw earlier. Then there is occlusion, where some part of the image is hidden. And then there may be a problem of illumination, shading. And finally, the background may cover, may actually, your image may be merging so much with the background that it would be very difficult for the image person to be able to understand that what am I looking at, because the background is so prominent. So these are some challenges that we have. I have a exercise, if the audience permits. Should we go on? Let us take on into a collab notebook for processing an image.
So there are some questions on the chat.
All right. I'll answer the chat. Okay. So Vashu is asking, what is the impact of changing color depth? Okay, Vashu, what happens when I have a image with a, okay, let us talk about your mobile camera. So my mobile camera used to be like 2 megapixels, then it went to 4 megapixels, then it went to 8 megapixels, then it went to 16 megapixels. Now you are having cameras having image resolution coming to 48 megapixels. So those megapixels are that how much information are we adding? Instead of only earlier there was color, then color, texture, depth, there is so much information coming into it that we have to strip an image of the depth, the texture, that brings it down to color. So the moment we change the color depth, if we increase the color depth for the single shade of red, instead of 255 shades of red, I would be having, if I take it to 16 bits, I would be having 16,000, no, 65,536 shades. Correct? So Vashu, when I'm moving from 8 bits to 16 bits, now my values change from 2 to the power of 8, that was 256, to 2 to the power of 16, that is 16,000 values. 16,536 something. I do not remember the exact value, but close to 16,000. So I would be having 16,000 different shades of red if my color depth is, instead of 8, 16 bit. Right? So when your images are 4K or HD, that means they are having a lot of color depth, which is allowing me to have a lot of different shades of colors, which you get as close to the real thing as possible. I hope that I have answered. So when I reduce the color depth, I am trying to simplify the image to its basic version, which would still allow me to identify what are the features, identify what am I looking at, identify where is the specific object located, and finally be able to visualize it as if a human was visualizing, barring that I'm not looking at complete information, I'm looking at only parts of information which are essential for a computer to understand what is this thing. Okay. Subhashini, you say which book should be referred to teaching this topic? I would recommend Decoding AI, obviously my book. But see, the topic is why it is easier for us in higher education, because we also teach a paper called computer graphics. So for computer graphics, it's the knowledge and understanding of images, particularly in very good detail. And that allows us to understand how images are formed, how digital images are processed, how digital images are working, what are color channels, and a lot of other things. But I have tried to simplify the topic so much in the chapter on computer vision that uh, any teacher would be able to very easily understand it. Okay. Okay. So people saw cookie, chocolate chip muffins, cookie, dog, puppy. Thank you so much. Okay. For the books, you can have a request to my publishers. I'm looking forward to more queries because the topic is a bit. Okay. I'll drop my email also here so that I can look forward to more queries, because this is what we are going to continue. Let us continue one part of the image today. How is the image processed? If it is okay. Subhashini says how to introduce this topic to class 10 student as if he is new to this topic. All right, Subhashini, I am going to take you forward to another course that we work on. Right? We run Method AI. On Method AI, we have a module computer vision. Right? And it is actually it has been written for students, keeping in mind that the students of class 7th, 8th onwards would be able to understand. That we are trying to make it so simple for anybody to be able to work with computer vision that see that what is the human vision system, camera vision versus computer vision, that when you capture an image with a camera, then it is simply a collection of visual information. It displays on the screen. Now, what happens when camera captures an image and you add intelligence to it? So when you are trying to understand visual information from that camera, so this is what I was speaking about, that image plus intelligence is computer vision. That what part of the camera acts as our eyes capturing the image, while computer vision acts as our brain which analyzes and interprets those visual inputs. All right. So when we apply intelligence to image analysis, that basically brings you to computer vision. The students can look at the examples, facial recognition, object recognition, medical imaging, augmented reality also, and they can go into solving some small questions like what is computer vision, where we say it's the process of teaching computers to see and understand visual information, which is an application because computer vision is related to seeing what or processing what we are seeing. So naturally, all these become out of question, analyzing medical images and likewise. So there are simple projects here like how to work with the Google Quick Draw with a step-by-step explanation for the student. Right? There is a pixel counter tool also that basically gets into programming with Python. Very small, simple programs where you can see that what is computer vision, which libraries are we using, upload an image, and then count it with the base of some pixel equal to some pixel plus count. And likewise. I hope that answers your query. Anything else that we want to discuss on the chat? I hope this was good enough. Subhashini, you can register for a trial version that runs up to 7 days comfortably. You'll be able to assess the Method AI computer vision module as well during the same. I guess we can take up more queries because I have 10 minutes. I can't take up the topic that we have already scheduled for the next session, definitely. But I am looking forward to. Sir, are there any queries on the YouTube window also? Thanks. May I request that we may close if there are no more queries? We are open to the queries. I have the session up to 5. I'll be very. Your
Sir,
queries are most welcome.
can I speak? Hello.
Yes, please.
Sir, I want to know if we want to introduce AI to 9th, 10th, 11th, 12th. So what all features we have to introduce? Could you please guide us?
Ma'am,
Ah.
for AI in general, you would be able to introduce it as a skill subject for without any knowledge to the students. There is no prerequisite.
Okay.
There is absolutely no prerequisite. The portions which you would require, they are the part of AI book itself because there would be a little bit of Python that they would require.
Okay.
And Python is an add-on module within the book, within class 9th also, what introduction they require, within the
Okay.
class 10th also. So
Okay.
the exercises, the lab component is Python and the understanding concept is AI.
Okay. So we have to use that CV2 for that computer vision and all. We have to import that module.
See, computer vision, yes, you can. I mean, by and large, computer vision, when we covered the computer vision module in the books, we have added examples of CV also.
Okay.
So you'll be able to go through. The examples are very friendly with Jupyter notebooks. They are
Okay.
step by step, again, available in the book.
Okay.
And I mean, with the basic knowledge of Python, everybody should be able to do it. See,
Yeah,
I wrote the
because
books. My thought process while writing the book was that I am a teacher. I
Correct.
felt a lot of struggle when I started learning AI, machine learning, computer vision, and all. So I wanted to create something which would be the most easy resource for a faculty to bring it to their students. So it's
Correct.
very convenient for the teachers, and in turn, it becomes very easy for the students as well.
Okay. 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 Because we are teaching Python, so I want to actually introduce AI along
You
with.
can very comfortably, if you are already teaching Python, you would find it very easy for you to bring it to your curriculum. And trust me, as an educator, I am into higher education. I have been to almost 80 schools in the last 2 years for teacher training programs. And I believe that ask us a query that this is before the session started. Ashish sir said that sir, the agenda, the objective of this series is just to make sure that all teachers are comfortable asking queries because the first and the foremost requirement for AI to spread is that the teachers adopt it. So we are doing everything in our part to make that happen. Ask any queries. We are available on email. You want us to visit your school and train the teachers. We are open to that also.
Okay. Fine. Fine. Okay. Are you giving any training sessions for the teachers if we want to enroll something like that?
Ma'am, this is what we do online. Where are you from?
I am from Pune.
You would be able to find, send us a request and we can even try to have a session there. Or I can actually, at least online, you want give us a topic that this is the topic we want you to speak on. Give me
Okay.
a time,
Okay.
and I would be happy to conduct a workshop.
Okay. Okay. That's what I want to know. What is the thing? Because I just actually I want to introduce AI along
Ma'am,
with the
please
11
drop
to
us a mail. Just I might look for, because I am working full time. So give us a flexible 2 or 3 days so that I can
Okay.
schedule that this is the day. But
Okay.
I'll do it free of
But
charge
if
for
you
you
are
for
having
sure.
the books, I can take it that books and I can go through as well if I have any doubts. If I am sending by
Yes,
mail.
Ashish ji has shared his email.
Yeah,
Just
yeah.
write him for a sample copy, and
Okay.
we'll be happy to send it to
Because
you.
I have enrolled for Method AI and I am trying some projects too. Sometimes that projects, I think it will be working only for 3 months. Again, we have to renew it.
You'll be comfortably. I mean, if you are enrolled for Method AI also, you'll be very comfortable teaching AI. I'm damn sure about it.
Okay.
I started learning from Method AI.
Yeah. It's very interesting also when I have gone through some exercise. After that, it stopped. So Ashish sir only has helped actually. So he told we can have 3 months if you are paying some amount.
That is so kind of you, ma'am.
Okay. Thank you, sir.
For sure. All right. I believe that is my time. Should there be no queries, we can close, sir.
Thank you once again, Dr. Sachin Gupta, for a very, very interesting session. We await some more such engrossing sessions from you. And thank you, all the participants, for joining in. Stay safe, you all. Thank you.